So first, thank you for letting the people from SAGE, many of whom are in the room today, participate in the meeting. These yesterday and today, we've heard a lot. I've seen a lot of you from last Friday, the 13th, in Brussels, and we learned a lot there as well. So let me give you a quick overview of SAGE. We haven't really talked about SAGE per se. It's a 36-month project that just started a few months ago. 16 million euros, of which 50% is funded by the Digital Europe program from the European Commission. IDC is the project lead. My name is Mark Dietrich. I'm with the company Bloodstone Consulting, which is my own company, and I'm operating as the technical manager in this project. Many of you may have known me in the past, and I'm still related to European Grid Infrastructure EGI Foundation. And in fact, this afternoon, I'll fly to Brussels, where, along with Raoul, we'll participate in the coordination meeting at the European Commission for the European Open Finance Cloud. So here, let me present these 10 use cases that we will focus on in this project. A lot of things have been said in this grouping about how data has been collected, how hard it is to collect data, how it'd be nice to have one place to go. But to some extent, that's not our objective. Our objective is to get these 10 use cases to work. And I'll talk more about them in a moment. And when we do that, we think we will create the conditions that will allow and provide a place for links to all the data that you have been talking about. So things, the net CDF, species occurrence, tables that might be downloadable from GBIF. These could be made available through the Green Deal data space. A lot of the things that have been discussed. There was even a presentation yesterday about how we're going to combine data set A and data set B and data set C, climate, hydrology, weather, blah, 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 and create some product data space that we will then use with for other analyses. So I saw that little piece, and I forget which use case it was. So that's a great thing that could be put into the green paper. So I'm going to provide a perspective about data spaces that doesn't match anything that you're going to read anywhere. But I wanted to highlight some of the things that are important from a functional standpoint about what data spaces should do. And I say should because they're not really yet at the point where they are doing it. So that's the aspiration. First, to enable data sovereignty by data providers and data rights holders. We had a conversation a moment ago about open data. I'll talk more about that in a moment. Second, enable data consumers to find the data they need. We're taking shall we say, a limited approach there, starting with use cases. But eventually, the idea is that a data space should make all this stuff available and make it find. That's findability is an important thing, an important aspect of FAIR, obviously, but it requires semantic interoperability. Otherwise, you cannot find things. So then we go on to say support interoperability at all layers, all of the EIF layers, the European Interoperability Framework. So technical, semantic, organizational, and legal. These need to work within the use cases I described, ideally across the use cases I mentioned, and other use cases that may appear in the Green Deal data space, as well as between data spaces. So how does that work? We'll talk about that. We need to maintain the data sovereignty of the data providers and data rights holders, even after the data is combined. We had a little bit of an argument about that yesterday, and the key is that we really don't have a roadmap for that. That's not something we've really talked about. Really don't have guidance from lawyers, ethicists, etc. There's some ideas, but in fact it's a little bit of an open discussion.
It will not work without.
We want value to be created from the data. We need to enable that. It is not our job to do that, but we need to provide the necessary framework and enabling conditions for that. We need to enable trust between data providers and their rights holders and the data consumers. So when you exchange data to somebody else, it goes from your control to somebody else's control. So how do you impose your requirements on that data consumer, that recipient of your data, to say, you are now bound by the rules that I set. And then how can I be comfortable that you are going to respect those rules? That's the trust framework. That is the actual place where the trust framework occurs, where you impose your will on that other party. So how do we accomplish that? The key point, data spaces do not store or process data. Yes, they work with metadata, but we're not a data repository. Data spaces are not data repositories. We're going to talk about that a little bit, maybe something we get involved in, but fundamentally, this is not the value proposition of a data space. So I'm actually borrowing from a presentation that I'll make on Friday to the European Open Science Cloud Coordination meeting, a little bit about interoperability. So interoperability it's a troubled, when we talk about open science and open data and interoperability, it's a troubled relationship, but it's not a new problem. This is a chart that I created for GREAT several years ago. So yes, we want things to be as open as possible, but in fact, many of these things are as closed as necessary. We have research data and public data. Mostly it's open, but it's not 100% open. There are lots of things in the research world, as we were sort of discussing before, where there's a requirement to protect things, endangered locations of endangered species in the GBIF environment. Let's say you're dealing in the energy environment. Well, where are the power plants? Where are the transformers? Where are the substations, et cetera? This is actually secure. This is sensitive information, which under the NIST II law must be kept secure. So how do you manage that, even though it's almost publicly available? There's obviously sensitive data, such as health and social sciences data, and of course there's industry confidential data that you might get by virtue of the fact that you have received it as part of a business research project, etc. So there are a lot of implications of all of these things. So what are our challenges ahead? I'm going to cut to the conclusion, and then I'll talk a little bit further about it. First, interoperability. Federated discovery, we do not have good solutions either in the data spaces or in research infrastructures or in the European Open Science Cloud. Yes, you can make a copy of everybody's catalogs and make a big catalog, but that's not a fix, and it's hard to keep up to date. So what's the way to do federated search and discovery? We need common data and services visibility, access, and use vocabularies. So we've talked a lot about things like ODRL, Open Digital Rights Language, but this is a syntax without any words. There's nothing in the dictionary about what to put into your sentence. So we need nouns, subjects, and objects that we can define the policies in. You can define your own policies, but please use the syntax that we understand and the verbs, the vocabulary that we need. This is important because it should cover both organizational and legal interoperability. So this is important for AI. So how do you respect copyright? How do you respect licenses, etc.? How do you define those things? So that I'm saying these things because this is important in the meeting that I'm going to present to in 48 minutes. Consistent logic for combining visibility, access, and use policies across when you combine data. I mentioned this before. Semantic interoperability. It's one bullet point, but it's a big one. And so we need tools to allow this to happen. We need the plumbing to support semantic interoperability. The solution that has traditionally been used in data spaces, if you look at the Data Space Support Center Blueprint 2.0, it says, pick a model. I mean, that's just not realistic. So we see lots and lots of domains, and in the Green Deal data space, we have so many different domains that are trying to talk to one another that the idea that everybody's got to agree on a single model is highly unlikely. So instead, maybe we should come up with some solutions that allow for conversions, crosswalks, mappings, etc., translations, the tables, the RDFs, what have you. I don't know what the right solution is, but I think we need to explore that. So that's all on interoperability. Cybersecurity, just to mention, it's not something we focused on in this meeting, but it's there. The data planes of different data providers need to agree on common frameworks so that they can there is security. There needs to be agreements to work together so that together the whole thing works together in a secure way. You cannot have islands of security that don't talk to one another. When there's a breach in one of the islands, they need to pick up the phone and call the other ones and say, by the way, we've got a problem. And you sort of propagate knowledge about the breach to the other islands so that everybody becomes secure. We also need secure processing environments. This is not security from attacks from the outside. It's security from threats or violations from the people who are inside, the people who got the data. How do you ensure that the people who got your data are not, in fact, going to do bad things with it? Well, you can't guarantee it. So secure processing environments, many of you have heard about this. I think this is an important aspect of data spaces that we need to think about. Not as something that a data space needs to provide the solution to, but it needs to work with. Now, it's nice that, for example, Simple, that architecture that the European Commission has built, they've said two things that are nice. The first is that visibility should be an important aspect of catalog operation. So data visibility, according to the rights of the consumer, should be implemented in the way your catalog operates. And then finally, I'll mention this before, data lab. This is a new idea that's been brought up in the AI Continent Action Plan, the idea of creating data labs. And somehow the data labs, if you ask certain EC people, are intended to solve the problems that data spaces have yet to solve. So my position is no, data spaces are the right places to solve this problem. We have the right tools. We know what we're talking about. What data labs can add to that is some of the storage and the processing that we do not have in data spaces. So there might be an opportunity there. I'm going to run through these pictures very quickly. The slides will be made available to you. The Sage data space covers a host of sins. It's big. It has these 10 use cases. It will probably have 50 more use cases if it works the way it is supposed to do. And within each of these use cases, there are going to be different groupings of people, which we call data user groups, who are going to have their own governance. And we talked about this a little bit before. Kathy was talking about choices of metadata. Well, you might make different choices about the metadata that you'll work with in each data user group, but you're going to be explicit about it. And that'll be something that is declared. And if data user group 1 wants to talk to data user group 2, they're going to have to figure out how to convert from metadata format 1 to metadata format 2. Easy peasy as long as we have some declaration of some transparency. The other thing I wanted to recognize is, okay, down at the bottom, you've got these little racks of equipment. Some of them might be secure processing environments. That's what SPE means. The boxes at the bottom are these connectors. This is here. Those of you at home can't see this. It says PEP, but in fact, it's a policy decision point. It's the place that implements the policies for access. And that's basically the place where you go from the data space to the data plane, or the control plane to the data plane, and you transfer that. There are going to be some things over on the right where the data space itself will provide services and may provide secure processing environments, or eventually, if it happens, data labs to provide that kind of storage capability, as well as common services like translation services. Here's another picture where we're actually looking at a bigger picture and involving some of the other infrastructures. Many of the people that are in this room, for example, GBIF is down here at the bottom. And we don't see GBIF as a data space, but we see it as something that we need to access. And so we need a data services wrapper that will allow us to get to the GBIF data in a controlled way without requiring GBIF to set up all these sort of data access requirements, etc. There are going to be other things like digital twins, asset administration shells, Blue Cloud, Destination Earth, AI factories. We also have the EOSC Federation being set up with lots of its own nodes, which I see as another data space with other sets of data user groups. So this is sort of one way of putting the pieces together in some coherent way. Very quickly, and this is the presentation I'm going to be giving in a few minutes. The question I was asked by the e-research group, e-infrastructure research group, which is meeting in Poznan now, is how does research data connect to data spaces? So what I'm doing is I'm listing the 10 use cases, and I'm giving you examples of the research data, the public data, the non-public data, and the pattern that use case uses. So I'm not going to dwell on this, but I'll call out a couple of things. Under public data, we have a number of them that do need geospatial data, marked in red. We also have some that do not require geospatial data. And then under research data and non-public data, in most cases, this is mostly not geospatial data. So the OGC world, the geospatial world, is not necessarily a requirement across the entire Green Deal data space. It's important, but it's not going to solve every problem. The other thing I wanted to note is there are basically two kinds of patterns. One pattern is, for example, at UC 8 and 10, which it's environmental data. Environmental exposures is what I call creating a big pile of data. So I'm going to assemble a whole bunch of stuff across all of Europe, across multiple layers: geology, hydrology, clinical health data, incidence of cancer, blah, blah, blah. And I'm going to create a very big database that says, if you know exactly what your latitude and longitude is, I can tell you what stuff you're being exposed to, what has happened there. There are other situations, such as this one here, the net zero defect manufacturing, where we're optimizing the supply chain and the manufacturing performance. There's no big pile of data there. It's supply chain data. It's point-to-point. It's supplier relationships. So it's a very different pattern. And that's all I have to say.